We don't have too many more of these left. So because we started out by doing day 1 and day 2 in day 1, this is the bonus lecture that you guys get. This wasn't taught last month in this course. And it's really powerful stuff, and it might be a little intimidating at first. And basically, I'm just going to show you new, slick methods that already exist to do a lot of the things that you've had to code yourselves. And it doesn't mean that as soon as you see these methods, that what you're doing before isn't good enough. It just means that when you become comfortable enough with these, that it feels natural to incorporate them, you totally should. And let's go. Okay, so first of all, let's talk about what a callback is. A callback is simply a function that another function takes as an argument and then calls. So in this snippet, we have a few functions. We have one called overseer, and it expects a parameter called num and a parameter called operator func. And you can guess what this is going to be. And then we have two simple functions defined below. One is add2, and it takes a number and just returns that number plus 2. And the other is multiply by 2, and it takes a number and returns that number multiplied by 2. And now lines 13 and 14 are where the interesting stuff happens. We log out, we call overseer on the number 10, and we pass it in add2. So now we've called overseer. Let's go back up and see what overseer actually does. So it takes one parameter called num, which we can assume, because I wrote this, that that's supposed to be a number. And then operator func, which you can tell by its name is probably supposed to be a function. And all it does is it returns the invocation of whatever operator func is on num. So that seems like a lot of weird stuff at first, without actually being able to really see what's going on. But let's see what gets logged. What gets logged is 12. So let's sort of reverse engineer that. You can see that we passed in 10 and add2 to overseer. And then overseer returns operator func, which is add2. So it just returns whatever operator func being called on 10 is. And here, add2 just returns num plus 2. And we fed it in 10 because it gets called on the first parameter of overseer, which was 10. Anyone not able to quite follow that all the way through?
Will you do it one more time?
Yeah, let's do it one more time. So we're calling overseer on two arguments, on the number 10 and add2, which is a function. And I don't know if that's actually something we've ever done until right now. So that's kind of a big, weird step. But it's awesome how it works. It's super fluid. So then we go up here into overseer, which we just called. And in here, num is going to be the number 10, because it's the first argument. Operator func is going to be add2, because it's the second argument. With me so far? So then all we do inside of overseer is return the invocation of operator func, which in this case is add2, onto num, which is 10. So we're just returning whatever this returns when you call it on 10. And all it does is add 2, so it returns 12. And we see that because overseer returns whatever this returns, and this is add2 being called on 10, it returns a 12. Cool. You don't have to be 100% comfortable with it yet. Just hopefully you're nodding along at this point. And then down here, same exact, same form. We're calling overseer again on the number 10. This time we feed it multiplied by 2. So then up here in overseer, num is still 10. Operator func is now multiplied by 2. So we're returning the invocation of multiplied by 2 on 10, which returns 20. And 20 is what we have down here. So I guess something that your mind might be going back to is when we talked about factory functions. This is different from factory functions because we're not producing a function. We're producing a result, but it's the result of calling a function that we don't even know what it is when we write this function on other parameters or variables that we create inside of that function. Yeah, Dan.
This might be a bit premature, but from a workflow perspective, I guess you'd say when should we be thinking oh, I might want to be making
Yeah. So let's say that you have a process that you do on some data, and there's a lot of preparation that might be very similar, but then different analyses that you would do. Like you might prepare the data in a certain way and then want to do something to it. but that something to it might vary depending on what that thing is, and you might do it multiple times, but with different processes, like you have a fork in what you want to do with some data, but you want to do each of them, and you don't want to write that prep every time. So a way to do it would be to have this overseer function that does some prep, takes a function, then calls that function on whatever it is that you've been preparing, and return that, and then you can wind up with sort of a split result. I'll try to come up with something a little more firm for you, but we do have some examples coming up, which is that many of the most top-shelf delectable built-in array methods expect callbacks, and they feed parameters into the callbacks in a certain way that you've got to understand in order to be able to use them. And we're going to talk about those. So this is a big case when callbacks are super handy. And our problem set today, I'll give it away, is we are going to write these in JavaScript, and that will be a fantastic example of when you would write a function that expects a callback. So let's start with .filter. So here we have an array which is not in order and contains lots of doubles, so has duplicates, and then we say var filtered r equals, and then we say array.filter, and that makes sense because we're calling .filter on the array. It's a built-in array method, so we're cool with that. And the fact that we're setting a variable equal to the invocation of .filter on the array suggests that .filter is going to return something. We might not know what it is just yet. Yes, Jeff?
So I find those methods reference them. Is that Mozilla
Yeah, MDN, Mozilla Developer Network, is great. You could also just Google javascript.filter, and the top 5 will all be exactly what you want. Yeah. And so we are calling .filter on the array, and here is the open parens, and here is the close. So inside of here is the argument that we're feeding .filter. You'll notice what it is. It's a function. And that function expects 2 parameters. One I've called val, and the other I've called in. And the way that .filter works is you can imagine it looping through this array, the array that you called it on. It has a built-in loop, and every time the loop shifts to the next step, val is the current value in the array. So what would be like array at I if we were doing a for loop. And in is the index, I. So then, within here, you can use val and in, and each time val is going to be just the element that's in the array, the actual value. In is going to be the index that you're at. And we talked about this method of filtering that we've done in for loops, and here it is in .filter. Now I'm returning array.index of, and I'm calling index of on val. And remember, index of returns the first occurrence of whatever you call it on in the array that you call it on. So, for example, array.index of 2 is going to be 1, because the first occurrence of 2 is in position 1 in the array. Is that cool? And array.index of 3 is going to be 2, because the first occurrence of 3 is in the second index of that array. So when I say return array.index of val triple equals in, I'm checking to see whether the first occurrence of this value in the array is the same as the index that we're on now. Now, in the case of 2, array.index of 2 is going to be 1. This is the first occurrence of 2 in the array. And as we're looping, I is always going to be where we're at. So when I is 1, we have a 2, and array.index of 2 is 1, because that's the first occurrence of a 2. So this is going to return true. And the reason that what you return in here is very important is that the .filter is a filtering mechanism for the initial array that you call it on. So whenever the callback returns true, you can imagine that that value is making it through the filter. Whenever whenever the callback returns false, that element of the array will not make it through. So let's talk about one that will not make it through. Let's say when end is 3, we have a 1. Now, what will array.index of 1 return? 0, because this is the first occurrence of 1 at position 0. So that means this is false, and we're returning false, which means that this one will not make it through. And when that array that's being built is implicitly returned by .filter, you can't see it, but it's what's happening, then this one will not make it through. This is the only one that will make it through.
So it's like a unique. It's put on unique.
Yeah, so you can build the callback however you wish. This callback I specifically fashioned to exclude doubles. We could also say return val modulo 2 == 0, which would be a filter for only even numbers getting through. Raise your hand if you're like real shaky on that. And I don't expect you to like remember it, but if you want to just talk through that one more time. Okay, cool.
You just created that. Is that how it
This
is?
is a built-in method, and I am using it how I want to use it. So the key part is .filter, whoever wrote .filter, didn't tell us what callback to use. We can use any callback we want. The only thing that will always be true in the callback is that it is passed 2 arguments. The first one is whatever value we're at, and we loop through the whole thing, so it's going to change. This callback will be called with val being 1, val being 2, val being 3, val being 1 again, all the way through. And the second parameter will be the index of the array that we're on. So far, that's basically just the same as a for loop, but different syntax. The new part is when this callback returns a truthy value, you can imagine that this value passes through the filter. When it returns a falsy value, the value does not make it through the filter. So what you're going to get back, what's returned, filtered array, can only be as long as the original array or shorter. It will never be longer. And when you use .filter, you use it with the intention of filtering your data on certain criteria. Those criteria are up to you, and that's how you decide how you want to write the body of your callback. I might have chosen a simpler callback for this example, but it's a particularly useful application of it. Yes, and
Right now, it's only returning the first instance.
that's right, yeah. It's returning the first instance because really the only time when this will not be true is when index of returns a different number, which means there has already been one as we're looping through forwards in the array. We'll have lots more time today to get super intimate with filter. And this is the exact same situation, just in this case, I've written the callback as a named function, and then I just feed it in by name. You can look at that later and make peace with how these two are actually the same, and I recommend trying it yourself. At first, I think it's a little bit simpler just to write the callbacks as anonymous functions in place because it's more visible, but as the logic in here grows complicated, you can just define callbacks as regular functions, which they are, and then pass them in by name as well. Okay, let's talk about another one, .map. And you'll see that there's definitely themes that are the same for each of these methods. So, like .filter, .map loops over the array that you call it on. It expects one callback, so all in here is just one function, one callback, and again, it feeds it the current value and the current index. So that's awesome. We got that for free because we just worked through that in our heads. And then you can imagine every time the loop rolls over, it's going to create a new element for a new array. So the purpose of .map is when you want to take an array and map it to another array, do something to every element, do the same thing to every element, and then create a new array as a result. So in this case, all I'm doing is, in the callback, returning the current value plus the current index. And you'll see when we call it on the array 1, 2, 3, we get back 1, 3, 5. And that's because on the first round of the loop, the number is 1 and the index is 0. 1 plus 0 is 1. On the second round, the value is 2 and the index is 1. 1 plus 2 is 3. And on the third round, the number is 3 and the index is 2, and 2 plus 3 is 5. And this is the array that's output. I sort of breezed through that, so now I'll take questions on it, and we'll go through it again. Yeah, Shay.
Value and index are always at the same.
They're always corresponding, yeah. It's always the value at the index. Yeah, it's there. If they were different, that would be pretty hard to make it be useful. Dave.
We can call those whatever we want, really, right?
Say it. Yeah, you can. These are just parameter names. Like any function, you call them whatever you want. You might as well call them what they are, so it's easy to remember. So, same real mechanism. Like you can imagine how these are written is very similar. Hint, you're going to write these, but it's a different purpose. With .filter, your purpose is to filter out certain elements from your array. With .map, it's just to perform the same calculation or process, whatever, and get a new array back. Check.
This is kind of a question a little bit unrelated, but why do you only write val instead of value when it takes like a half second to write value?
Yeah, that's fair. For me, seeing
And, like,
one
I always
syllable
see that, I always
things.
see that in all the problems, like array instead of array, it's ARR, num instead of number, it's num.
I find that people's minds, I know my mind anyway, can parse words much faster when it's one syllable as opposed to two. And I try to keep to as few syllables. Also, the more characters here, the more noise there is. Yeah. Any other questions on .map? Yes.
Do that like with a nested,
Say that again?
like if the array has nested arrays.
Yeah, you can do this on right because we actually have written a recursive .map, which was a lot more complicated than writing a non-recursive one. Let's say you have an array of arrays, and all those child arrays like have a certain structure or something in common, and you want to on each of those child arrays perform some operation. You can use .map on the outer array, and as so long as you expect in your callback that val is also going to be an array. Like this would throw an error because you can't say array plus a number. But if you write your callback such that it expects value to be an array, that's completely fine. You can call these methods on an array of objects, an array of numbers, array of strings, array of arrays, whatever, so long as your callback knows what it's getting. Yes?
Just to be clear, all these methods we're doing right now apply with arrays. We use them on
Yeah, good question. I mean, they could have been either way. They could also have a built-in for-in loop, but these are only array methods. Okay, for each. Here is a little bit of a simpler one. It's a bit dinky. It's kind of a cheap thrill method. I don't like it, but it's really common, and we're going to go over it. So again, it has a built-in loop. You call it on an array, like this. So array.forEach. It takes the callback as well, and it gets the exact same thing. So now this is getting like pretty easy. The difference is it doesn't return anything. It's kind of like a throwaway, do whatever you want method. The callback can do whatever you want to other variables that exist in the scope, but because it's essentially just a wrapper for a for loop. Like here what I'm doing is we're calling for each on this array, which is just 1, 2, 3, and each time we get the value and the index, and there's this variable num on scope up here, which starts out as 1, and each time through the loop I'm just multiplying num by whatever the value is in this array as we're looping. So first it's 1 times 1, so num is still 1, then it's 1 times 2, num becomes 2, then it's 2 times 3, and num becomes 6 at the end. This is nothing you can't do with a for loop, and actually a for loop is it performs a bit faster because it's a slightly lower level thing. It's this is like a wrapper on a for loop, so you can imagine in the background the interpreter doing a tiny bit more work. People use for each all the time. I've heard from the people I respect the most that you can generally just use a for loop instead, or when you have a specific purpose, .map or .filter, one of those will often be what you actually want to do.
Yeah, I feel like .map does the same exact thing. It performs the operation on every single value.
Yeah. So
All these systems.
yeah, right. .map is great when you know you have an array and you want to produce a new array from it. When you just want to do an operation using every element of an array, you can just use a for loop. Some people use for each because it's a little easier to type and it's like fancier and it's got a callback and it's fun. use a for loop instead. But now you know for each. Yeah, I said it. Okay. I'm a little scared to talk about this one. I rarely use it. It's a lot to think about. It's super powerful, and there's a lot of writing on this slide. So this is stacked against us, and we're going to crush it anyway. Okay, dot reduce. First, let's just look at the code snippet before we talk about all the writing that I wrote. This is definitely left over from the snippet above. Do ignore this console log call. But on line 52, we create this array. Just has 1, 2, 3. And then we create a variable var sum. So probably what we're about to do is to sum the elements of this array. And then we set sum equal to r dot reduce. And look what we fed reduce. We fed it 2 things this time, which is unlike the other methods. We fed it a callback, which starts here and ends here. And then we fed it a second argument, which is 0. Now that 0 is the starting point. It's what we start with. And you'll see what that means in a second. So this callback takes more than just 2 parameters. It actually, so I've written 3 in. It actually takes 4. The first one is the previous value in the loop. Now, in the first time in the loop, when you're at the first value, prev actually refers to the starting value. And the starting value is very, very important, or else it's going to return undefined because it started with nothing. And current is the value of the array that you're currently on. So it'll be, this will be current, then this, and prev will be the starting value, then 1, then 2. Now, at the end of the loop, reduce actually returns what the callback returns. So you can think of, you are reducing an array into one thing. Now, let's follow through what's actually happening in this example. So when .reduce starts its work, int is going to be 0, current is going to be 1, and prev is going to be 0, because that's what we fed in as a second parameter. And the callback returns prev plus current. So 1 plus 0. Now we go to the next round of the loop. Now prev is 1. That's how, you weren't supposed to guess that. That's just how reduce works. Prev is whatever is returned the previous time by the callback. So now the second loop through, prev is 1, current is 2, and end is 1. Now we return 1 plus 2. And so on the third time through, prev is 3, current is 3, end is 2. We're not using it right now, but it's there if you want it. And we return prev, which is 3, plus current, and because now we are at the end of the array, that's what all of reduce returns. So it's like we're reducing the array into one thing that we've been like squishing it together as we loop through. Questions? Well, this exact example, I believe, would just rebuild the string, because that's what happens when you add string characters together.
So it just make one string.
Yeah. Oh, so yeah, if you call it on an array of string characters, of strings, it'll make one string, exactly. With this exact callback. And remember, the callback can be anything you want. We'll talk about using reduce on other data types in a second. John?
If you have a long array, is there a way to set up a stop point?
A stop point?
Yeah, let's say you have like arrays that go in line.
Yeah, I don't believe there is with the built-in methods. That would be a case for a custom for loop. You could definitely, any of these methods are not hard to recreate with a regular loop. They're, yeah, this would take it all the way through. I mean,
When you're saying previous, are you meaning the previous like value or like the actual what it actually is in the array? So
great question. Yeah, prev is not the value before in the array. Prev is what the last loop of the callback returned. Yeah, I bet a lot of you had. That's a great question. Dan?
My question's actually kind of adding on to that. So is it just so like the reassignment of like value of prev, is that just sort of built into?
Absolutely. Yeah. There's nothing about a for loop that like carries through what the last round of the loop did. This is baked into the method. And yeah, it's fundamental to just how it happens to work, and it's the first time you're seeing it, so it'll take getting used to. Any other questions on this example before we go to another example? Reduce, yes.
For adding 0 there, does it have to be 0 or it could be like anything you want to do?
We could start the sum at 100 if we want to. It would just return 106. Yeah, reduce doesn't care what you're doing. It doesn't know if you're being smart or not. All it knows is what to do every time. And so this value, it's only used once. And the only time it's used is at the very beginning, when you're at the first element of the array. Prev needs to be something, and it's your starting point. That's it. Yeah, Dan.
Can you use it to add up like key values and objects? Like separated?
I don't know. Let's see what the next slide does. It's a great question. Yeah, turns out you can. So you can use it on any data type so long as your callback is expecting to deal in that data type. Kind of a contrived example, but I wanted to keep it as simple as possible. Here we have, right, so you can build whatever you want, but it is only an array method, to be more specific. Yeah. So you can only call it on arrays. Here is an array containing a cat, a mouse, and a fish. And we are creating an object this time. So we are, I would say, mapping an array onto an object. We're reducing an array into an object. Again, .reduce takes 2 parameters. This time, it is a callback again, but our starting point, it's not 0, it's an empty object, which makes sense because we're going to build an object. And our goal, you can just look down here on line 50, we're going to build something like this. It's maybe like a proper nounifier, where it takes a kind of animal, and then it makes that animal a key, and the value is that animal as a name. It just capitalized the first letter. I needed to do something. So that's what this is going to do. And you can see how this, on the right side of the equal sign, all that's doing is just capitalizing the first letter of a word and lowercase-ifying the rest of it. So this and this you can just write off as transforming this kind of cat into this kind of cat, this kind of mouse into this kind of mouse. So you can put that on automatic in your brain now. Now let's walk through. So we're starting, reduce is starting. We're on the first element of the array. Prev is going to be our starting point, which is our empty object, which we chose very deliberately. Current is going to be this cat. And now end, again, is going to be 0. Again, we're not using it here. Now look at what we do on 46. Remember that prev is an object. And we wrote this callback, so we know that prev was an object. And we're saying prev at current equals blah, 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 just capitalize the first letter. So we're assigning a key value pair to this object. And so on the first round, we assign this key value pair. Little cat is big cat. And then the next time going through, and then, very important, line 47, we return what prev is now. If we didn't do that, we wouldn't save our work from before. Actually, worse than that, prev would be undefined in the next thing, and it would throw an error. Jess, do you have a question? And so then the next time through, our object just looks like this. It has a little cat and a big cat. And then prev is cat, cat. Current is mouse. And so then we say prev at little mouse is capital mouse. And then we return that. So then the third time through, we just add the fish. Same deal, repetitive. Questions on this example?
I'm not so sure I get the point of prev in this example. In the last one, it kind of made sense with the numbers, but here.
Yeah, well, think of it this way. When you are building an object, you can't start with nothing. You start with an empty object. Every time through the loop, we're assigning another key value pair. So in the starting point, we have to, if prev was undefined, we can't say undefined at cat equals uppercase cat. It's not going to know what to do with that. Prev has to be an object. And so as we create the starting point as an empty object here. We could also make the starting point be an object that is loaded with things, and we're just adding more things to it. This could be a named parameter that exists, a named variable that exists somewhere up there. Is that fair? Dan.
So in the, you can think of like the second argument that you give to the function inside like the nested function, the name which I can right now. Like,
Call that.
Right. Like the data type is the second argument, is like the data type brought to you. Like no matter what.
Yeah, yeah,
Like in the
totally.
in the previous one, we gave the numbers we wanted to.
Absolutely, yeah. That's a real easy shortcut to put in your head. You're gonna feed it generally an empty, nullified, like zeroified. If it's a number, it's often going to be 0. If it's an array, it's often going to be an empty array. If it's an object, it'll often be the empty object. But it's going to be the same data type as what you're ultimately returning. That's true for sure.
How then would you, like, if you wanted to deal with a string as a result, would you give it like an empty string?
Yeah, absolutely. Yeah, if we were doing, like what Emily asked before about .math, but we were doing it with reduced, you'd have to feed it an empty string to start with, or else it's going to have the word undefined at the beginning of the string that you're making. Any other questions on reduce here? Okay. Don't stress if you aren't 100% on this right now, because I've known about this method for a year, and I've used it in production once. It's pretty complicated, but it's also extremely powerful, so you should be familiar. A lot of things are written in it, so when you want to reverse engineer modules that you're using in your code, you'll want to be able to read through it and know how they work. Okay, raise your hand if you're like totally saturated and don't want to learn another method right now and want to start the problem set. Okay, raise your hand if you want to learn about .sort. Okay, cool. I just wanted to make sure because this is like a lot of new kind of intense stuff. This is the last one. We'll talk about .sort. So sort is a very different, it's a different mechanism. You've used it, and it does some expected things sometimes, and it does some weird things sometimes. You've probably used it on an array of numbers without a callback, and seen that it only sorts the numbers by the first digit, which is pretty frustrating if you've got double or more. You almost never need to do just tiny little numbers like that. And the trick is because .sort is smart, but it's only smart when you give it a callback that explains what you want it to do. So here we have an array, 3, 2, 1, not in order this time. And we just say array.sort, it gets this callback, which we'll talk about in a sec. Now when we log array is 1, 2, 3. It's in order. So .sort, you can already tell, is different from the other methods we've been talking about in that it doesn't return a new array. It actually transforms the array that you call it on. And if that's something you don't want, you'll do it like this. Array.slice.sort, or .slice creates an exact copy. We were talking about it yesterday in the case of pass-by reference and pass-by value. Okay, let's talk about this weird callback now. It gets 2 parameters, A and B. And what you can imagine is .sort is looping through this array over and over again. We wrote bubble sort. It doesn't sort by bubble sort because bubble sort is not a terribly efficient method of sorting. But you can just imagine it's kind of like that for now. And each time on its loop through, A is one element in the array, and B is the next one. Now, I'm returning A minus B. That's completely arbitrary and random. So why am I returning A minus B? If this callback at this moment returns a negative number, these two things stay in the position that they're at. If the callback returns a positive number, .sort switches their position. That's just how it works. And it gives you that functionality so that you can control the order that you wind up with. So in the case of an array of numbers, when I say return A minus B, if A is 3 and B is 2, am I returning a positive or a negative number? Positive. Right. And so when I say return A minus B, the 3 and the 2 are going to switch, and we'll have 2, then 3. So this is what you do when you want to sort in ascending order. If I said return B minus A, it would say exactly as is, because that's what you do when you want descending order. Then it moves to the next one, and so now this is A and this is B, and it does the same thing. And it does that over and over until it goes through without changing anything. And then it's done. And you have your array sorted however you ask the callback to make it sorted for you.
It's not the same logic of bubble sort, though?
Except it actually does something different in the background. The way I just described it is exactly the same logic. I have to admit I don't know the exact algorithm it uses. It's more efficient. Bubble sort is not efficient for long, long things.
Uses a variant of quicksort.
Say it again.
The JavaScript engine uses a variant of quicksort.
A variant of quicksort. Yeah, there are many sorting algorithms. You can watch some of them done as gypsy folk dances if you look for that on YouTube. It's pretty okay. Okay.
Does that work with strings too? Is it the same way with strings?
It does work with strings.
Okay.
It works on arrays of strings. It doesn't work on strings themselves. Strings are immutable. They're a pass-by value only. But if you have an array of strings, what happens is each string character has a character code that it corresponds to, which is a number. And you can look up what those codes are, but the strings are sorted in, it just transforms the characters to their code numbers, and then it sorts them that way. So it still happens numerically, and you totally can sort an array of strings that way. So it's a really quick alphabetizing strategy. Yeah, Normy?
So I mean, is there any other way you want to use sort besides like having like in like a numeric situation or like an alphabet situation, or is that normally where
You guys ask questions at the best times. So, what have I done here? Yeah. Cool. So, and those of you who did the extra challenge that I gave you got like real familiar with this without any introduction, so nice work figuring it out. Imagine we have an array of objects, pretty aptly named with a more than one syllable name this time. We call sort on it, and again, this callback will always get, it's very often called A and B, but what it is you can imagine these changing such that they are one element in the array, and then the next element in the array. I'm returning A.keyname minus B.keyname. Now, in this case, whatever the value of keyname is going to have to be a number or a string, or subtracting one from the other isn't going to work. But this is just going to alphabetize the objects by whatever keyname, whatever key and value that is. So if we had an array of like person objects, and instead of keyname I wrote first name, it would reorder the objects in ascending in like alphabetized order of their first names. So it's the exact same mechanism, but it's being done, you're accessing a property of the object in order to sort the array of the objects themselves. And one step further, this callback doesn't care how much logic is in it. It follows the same rules every time, which is if it returns a positive number, the order is getting switched. If it returns a negative number, or the order is staying where it is. If it returns 0, it's like random whether it switches the order or not. No need to explicitly return 0. But if it returns a positive one, or a positive number, that's the only time when it's definitely flipping the order. So, let's say I want to order my array of objects, and first priority is to order by key 1. So I say if A.key1 is greater than B.key1, then that's the order I don't want. I want them to switch. So then I say return 1. And I've returned a positive number, so A and B are going to switch places. However, if A.key1 is less than B.key1, return -1, which means move on to the next round and leave things as they are right now. Now let's say A.key1 and B.key1 are equal, which is the only way I'd make it past line 87. Then let's say second priority is to sort by key 2. So then I say if A.key2 is greater than B.key2, return 1. Otherwise, just return -1 and we're good. So that's how you prioritize and incorporate multiple fields on an object in your sorting. This is super advanced. Yes?
I don't get the return 1 part, how that organizes it.
Yeah, so I just chose 1. It can be 100 or 1,000. The important part is that it's positive. When the callback returns a positive number, A and B are switched in the array. So you can use that however you want. But this is one scenario in which I want them to switch. Let's say I'm sorting in ascending order alphabetically or numerically. If A.key1 is greater than B.key1, I want them the other way around. So I'm just returning any number that's positive. And the reason I explicitly return -1 here is because I don't want to sort by key 2 unless key 1 is the same. So I have to check both of these cases. Dan?
So, cool, great, like,
Awesome. Anyone else?
that's it. But like also, so I get how this could be totally useful, like if you were like alphabetizing with these numbers or whatever. It totally makes sense because it's like if the character code of like, as long as the character code of the string like makes sense with what you want to do. Do you know what I mean? Like so if like assuming that like B has a character code that's higher than A, like I would be able to intuitively use this to sort alphabetically because I'll like assume correctly that that's how it's structured. But like if you want to do something like more creative or less orthodox, I guess, you would like how would you know like what to refer to make sure that it's going to do what it is that you want it to do?
Customize
Yeah.
lines.
So say what?
Like you can customize 86 and 87. So, I mean, ideally, you set up the objects with the proper key value pairs. So you do that. But if it's something really funky, like I want blues to come before yellows, then you say you put that into language, right?
Yeah, totally. So this like A dot key one, B dot key one, or A and B logic, that only works, and with the like math expressions built in, that will only work if you're dealing with numbers or strings. If the thing itself is a number or string, or if the value you're referencing is a number or string. If you want to have more unique logic to you, like order by color or whatever, then yeah, you would have to say like if A dot color equals yellow and B dot color equals blue, return 1, something like that. You could build that yourself. And as far as what the character codes are, that it does. So they are smart enough that they made it be that way. So capitals come before lowercase. Capital character code, capital A, I believe, is 65. Capital Z is 65 plus 26, and then lowercase a is 97, and lowercase z is whatever that is plus 26. Then there's a whole lot of other characters, obviously, which might seem arbitrary ordered. But if you have word codes, word strings, then you can just assume that that sort will sort them alphabetically. Yeah, so this can get as weird as you need it to get. Super powerful. Rarely do I really do something other than just this, but stuff like this happens as well. Any other questions on this slide? Just about done. Cool. And just one last little fun thing. You can chain these. So remember how like filter, map, reduce all return an array? So because they return an array, like this thing, ending here, starting here, it's just an array. So then I can chain a dot sort on that. In this case, what I'm doing is we have this array, a bunch of numbers, not in order, and it has duplicates. So the first thing I'm doing is applying that usage of dot filter that we did on the first slide. And so what that's going to do is get rid of the duplicates. Then I'm chaining a dot sort call on that, returning a minus b, which will sort it in ascending order. And then what I have is this nice sorted array with no duplicates. And this is just to show you what you can do. Something like this, it's totally acceptable to have in your code. You don't want to go crazy to make it like hard to read. That's what a lot of people do when they first start learning cool methods, is they're like, let me see how condensed I can make it. And what they do is create code that's really hard for anyone else to read and hard for them to debug. But any function that returns an array, you can just chain another array method right onto that. It's there for you if you want. Yes. Whoops.
I've done that.
Yeah.
And so what would be the better way to like do one step at a time, kind of like?
A great way to control yourself would be to, so when let's say I chain 3 things, there's no variable declaration in there, because really like this is going to be whatever happens at the end of that. A good rule of thumb to follow is every time you do something, create a new variable with a descriptive name of that explains what you've just done on it. And that way you won't let yourself chain too many things, so that by the time you actually have something to refer to by name, you don't even remember what it is you've just done. So that's a good way.
And there's no cost, or the cost of whatever the cost might be to the computer.
Yeah, I mean, creating a variable does have a cost, but it also has a cost when developers can't find a bug and lose time and code breaks in production. So it's always a balance. Creating a variable does not cost very much. Yeah. And you've seen this. I just thought I'd throw it in again formally because we're talking about weird function stuff. IIFE or IFE stands for immediately invoked function expression. This is not a function declaration, even though it seems to start with the word function. We say it's a function expression. Remember, var blot equals function is an expression. When you just start with the word function, then give it a name, and then write the body, that's a function declaration. This is an expression because it actually starts with an open parenthesis, not the word function. And the closing parentheses here, just invoke it right away. So this code runs in place. It's not like writing a function and then calling it later. So we create this random number, we log it, we add it to number, and in this case, the random number that we get is 6. And then because we added it to this number is now 6. But out here, when we try to log random num, we can't see it because it was created inside this local scope. And even though it runs in place, those scoping rules do apply. And the reason why I say that randomly is because a lot of the time, what this is useful for is because it just runs in place. So why even have it be a function? Well, if you need to create a lot of variables and you don't want them clogging up your global scope, this is a way of doing it such that these things will not pollute your global scope because they're only accessible within this scope. A side thing. I never use them. A lot of front-end developers like them. Nice work staying with that one. So a quick word on the problem set today. Just want to show it to you. And again, it's not like, okay, you saw this, so now like every time there's an opportunity to use one of these, make sure you do it or you're wrong. Implement them, like add them into what you're doing very gradually and take your time with it. It's not till I really started the like at-home portion of full stack that I even used a single one of these ever, even in practice. So this wasn't part of the course before, so today is called Callbacks, and what I ask you to do is make a myFilter, myMap, myForEach, and myReduce, basically clones of filter, whoa, this is teeny tiny, clones of filter, map, forEach, and reduce that perform and are called the exact same way. So here is the explanation. I ask you to add these directly to the array prototype so that they're not standalone functions that you call and feed arrays into, but you actually call them like array.myFilter, array.myReduce. And I thought that would be fun because we got pretty deep into prototype chains, and you saw how to like make a construction